Hey guys, Mr. Backerberg here. In this video, we're going to take a look at the number e. So e is called the natural base, but where exactly does e come from? If we think about part of our compound interest formula, we've got 1 plus r over n raised to the power of n. Well, as that n value, as those number of compoundings increase out to infinity, this whole thing is going to approach e raised to the r. So we can actually start to estimate e by doing some stuff graphically. So we're going to look at the equation y equals 1 plus 1 over x raised to the xth power. And I'm going to graph that out on my calculator, and we're going to see if we can estimate or approximate what e is. So I've got that equation typed in. I'm going to hit graph. And what we're going to look at is as our x values increase forever and ever. So I'm going to hit trace, and I'm going to arrow to the right. And I'm just going to let this scroll over to the right for a while so that we can start to approximate what this e value is. So as we keep going, we can see that those y values are slightly increasing. It doesn't necessarily look like our graph is going up any higher, but if we focus specifically on those y values, we can see that they are still going up. And as we go further and further out to the right, notice that those y values aren't increasing as quickly as they were before. Now this is actually going to take a while for us to get out to what e actually is, so I'm going to switch over to the table. But before I look at the table, I'm going to change some things. So I'm going to hit second and window, and for my delta table, for how much that table is going up by, I'm going to go up by 100 each step. So now if we look at the table and we scroll out to x values that keep getting bigger and bigger, we get to a point where our y values haven't changed in quite a while. We're at almost 14,000, and we can see that these last few y values have been exactly the same. So we can approximate e to be about 2.7182. Now, e is a lot like pi in the sense that it's a non-repeating, non-terminating decimal that goes on forever and ever and ever. So there's no way for us to really lock down exactly what e is, but we can approximate it fairly closely. Now, what we can do with e is doing something called continuously compounding. So we looked at compound interest where we did a certain number of compoundings per year. Annually was 1 time per year. Quarterly was 4 times. Monthly would be 12 times. But there's this thing called continuously compounding where your account is, like the name implies, just continuously gaining interest. So if your account begins with a principal amount P and earns an annual interest rate R, compounded continuously, then the value of that account after T years can be modeled by the equation A equals P times E raised to the power R times T. That's your compounded continuously formula. So if we look back at our compound interest example where Bernie had deposited some money. He deposited $2,500 in an account, getting 5.4% annual interest, and we left the money in the account for 10 years. Let's say we were compounding this daily, so every single day Bernie gets some interest. So that would be 2,500 times 1 plus the 0.054 divided by, well, daily, there's 365 days in a year. We would take 365 times the 10 years. If we were to type all of that into our calculator, we would end up with $4,289.85. So again, more compoundings, more interest. But if we look at doing this compounded continuously, now we have to shift our formula a little bit. We're still going to deal with that principal amount, but now we're going to multiply by e raised to the power of that interest rate, so 0.054 times the 10 years. And if we were to type that into our calculator, we would get $4,290.02. So if we look doing this daily versus doing this continuously, there's not that much difference in the interest really. It's about 17 cents. But anytime you're trying to maximize the amount of interest you're gaining, you want to compound as often as possible. That's going to be it for this video. Thanks for watching.